So today we're looking at identity and inverse matrices. So they're just different types of matrices that you can get. So we'll start with the identity matrix. So the letter I represents the identity matrix. Okay. Now the identity matrix has the following features. It is a square. Okay, so it's got even rows, and the same rows in the same columns. It has ones on the leading diagonal, top left to bottom right, and then all the other digits are 0. So you can see here, okay, this is a matrix that's only got 1, so that's why it's there. This one, you've got your ones going down the diagonal, again down the diagonal, and the rest of the numbers are 0. So that's what an identity matrix will look like. Now, when multiplying a square matrix by the identity matrix, it is equivalent to multiplying by 1. Okay, so if you have a square matrix, okay, any square matrix, so if you've got a 2 by 2, so like this one, A, you've got a 2 by 2 matrix. If you multiply it by the identity matrix, which will be this one, okay, and it is because you've got your ones going diagonally, and the other numbers are 0. So if you're to multiply them, it's the same as if you're multiplying the matrix or a number by 1. So if you have 2 times 1, it's 2. If you have a matrix times the identity matrix, it's the matrix. Okay, so it has it here, it's multiplied I times A here, and it just equals A. Okay. The next part, so it's saying that multiplication is commutative, which means it doesn't matter where the identity matrix is placed in the equation. So that goes back to when our normal multiplying rules, when we have, 4 times 2 is 8 and 2 times 4 is 8. Okay, so it doesn't matter whether you have the identity matrix times A or A times the identity matrix. Either way, you're always just going to end up with the original matrix, which in this case you get A. Okay, now remember that's different if you're multiplying 2 different matrices and neither of them is an identity. Okay, so such as this one, so A times B equals one thing, but B times A equals a different thing. Okay, so that's very important. So multiplication of matrices that aren't identities don't go back and forth, but with the identity it doesn't matter about the place. Okay. The next one is a matrix. It's called the inverse matrix. So we write it as A, so A is just the matrix, to the power of -1. So just in your CAS, once you define your matrix as a letter, you just do your matrix and then to the power of -1, and then hit enter, and it'll give you your inverse matrix. So the inverse matrix has the following features. Multiplying a matrix by its inverse will result in the identity matrix. Okay, so the rule, you have a matrix, you multiply it by its inverse, and then you'll get the identity. Okay. So that's what's showing here. You've got your identity A, you're multiplying it by its inverse, which we found over here. Okay, and that it equals the identity matrix. Okay. So, not all matrices will have an inverse. Okay, not all matrices you can do to the power of -1. So there are some rules. Only square matrices will have an inverse. Some square matrices will not have an inverse. And to find out whether it does or not, you need to find out and calculate the determinant. If the determinant is 0, the matrix does not have an inverse. If the determinant is not 0, the matrix will have a determinant. So I think, if the determinant is 0, there is not an inverse. And if the determinant is not 0, the matrix will have an inverse. I think that's wrong here. That's why it sounded weird. It will have an inverse. Okay, now we're going to go into how to find the determinant, which isn't too tricky. So, to figure out whether a matrix has an inverse, you need to find the determinant. Okay, it's a test for finding if a matrix has an inverse, is the determinant. Okay, so a rule for a 2 by 2 square matrix, the determinant is, so this is A, okay, and the numbers inside are just A, B, C, D. To find the determinant of A, it's A times D, so these two, and then times B times C. Okay, and then you subtract them. So yeah, A times D minus B times C. Now, depending on your answer, if you get 0, that means there is no inverse for that matrix. But if it doesn't equal 0, the inverse does exist. So here's an example for this one. You've got, A equals 1, 2, 3, 4. To find the determinant, you go, actually we'll use my pen. You go 1 times 4, which is 4, and then you go 2 times 3, which is 6, and then you subtract, so 4 minus 6, which gives you -2. Okay, because the determinant is not 0, that's what this means, -2 is not 0, that means the inverse of A does exist. Okay, so there's 3 different parts here that you need to remember for 5H and 5I, but as long as you stick to all the rules, you should be fine.